Okay, pre-calculus 12, let's get after it. Here's video 22, and we are going to jump into the properties of logarithms. So similar to our exponential rules, we have a bunch of rules for logs. So let's start. The first rule is the product rule, and it tells us this, okay? The log of base b of a times b is equal to the log of base b of a plus the log of base b of b. So you can see here we have an example. Log base 10 of 3 plus log base 10 of 7. They have the same base, so we can write them as log base 10 of 3 times 7, which is the same as saying log base 10 of 21. So you're allowed to do that. I want you to do that. Oftentimes you'll go the other direction. You'll go from this to this to this. You'll see why and when in just a few slides, okay? But that is the first law. If you have two factors, you can break them apart, but you can also multiply them together, all right? So that is the product rule. The next one is the quotient rule. So very similar, but in this case, it's now division of the logs gives subtraction. So much like dividing a common base subtracted the exponents, now if we have a division of the object of our log, we subtract the two individual logs. And you're going to want to be really careful with subtraction. Again, you'll see this later on. But here, log base 10 of 36 minus log base 10 of 4 can be written as log base 10 of 36 over 4 altogether, which is log of 9. Boom, simplified, done. So that's the rule. And again, it's harder to go from here to here to here, but it's allowed. Oftentimes, this will be a tricky step that we try to disguise to make questions look a little bit more challenging. Next one, the power rule. This one's a big one. You also need to be a little careful on how it can be used, but overall, it's relatively straightforward and quite helpful. So it means that the power of the object of the log can be written as a product of the entire log in front of the expression. So here you have log 5 to the 125. Well, what does that give us? That gives us log base 5 to the 5 to the power of 3, because 5 times 5 is 25, and then times 5 is 125. And then what you can do once you get that exponent is it can come down to the front of the log. So now you have 3 log 5, base 5 of 5. Now, this is also going to introduce us to another rule, and it's that log of base b to the same object is equal to 1. Because just think about this as moving to an exponential, right? Base of my exponential, exponent, answer. So if these are the same thing, they cancel out to 1. So this just becomes 3 times 1, which is just 3. So if you can ever get to this scenario, your log can cancel out with its object. It's very helpful, very handy. Now, change of base rule. This is a big one. This one threw me for a loop for quite a long time, but it actually, when I was looking at something, when I was sort of learning my way through this stuff, I was a little unsure of how to proceed at one point, but I've kind of tied it all together, and there's a really important message that was missed when it was explained to me just a couple years ago, and that's you can change to whatever base you want. So what do I mean by that? You take log of a certain base of an object, and you can write it, so just like this, to log of the first object to whatever base you want, and that's what it is. It's whatever base you want. But almost always, we will just put it to base 10 log, and then over the same base that you've chosen to the original base of the log. So the base 3 now becomes the object of the log. And the reason why we would almost always do it that way is because a base 10 log we can plug into our calculator. So now you can actually go log of 5 divided by log of 3, and you get 1.465. So changing to a base 10 log is super helpful because we can plug that number now into our calculator. You cannot plug that into your calculator, unless you have a calculator that allows you to input different bases, but most of them do not, which is why changing the base is crazy helpful. Now, the other thing is, and this is one that I wish I had been taught explicitly years ago, was you can change this to log base e if you want over log base e of 3. Because remember, that base becomes your new object in the denominator. And what was log base e again? Well, that was natural log. So you can convert a regular logarithm into a natural logarithm by changing the base to base e. And you can use this on your calculator as well because you do have also a natural log button. So you can go natural log of 5 divided by the natural log of 3. And you do get the same answer. You should get the same answer. The natural log is a different application, but the result should be the same. So changing the base to e allows you to use natural logarithm. So that's the first few rules. In the notes, you'll find that there's a ton more. There's a list of about six regularly used ones, and then there's a list of about five more that are a little bit more obscure, but they can still be used often. So have a look through the notes, remember, on my website, and you can start getting more comfortable with using the rules whenever you have to. Now, we're going to put it all together here. These take a little bit of practice, but let's do what we can do. So this question says, write each log in terms of log 2 and log 5. Okay, well, we got log 40. So let's start by breaking this into factors. What's log 40? Well, log 40 is log of 5 times 8. Now, I'm going to stop there because I know that 8 is 2 to the power of 3. So we're going to start by using the product rule. If I'm multiplying those things together, I can then write them as separate logs using addition. So now I have log base 5, or log of 5 plus log of 8. Remember, if I don't mention a base, they're base 10. So now we need log of 5, which we have, yay, but we also need log of 2, which we don't have here yet. But, like I just mentioned, 8 is 2 to the power of 3. So we can do that, and then we use our power rule, and the 3 comes down to the front. So we get log of 5 plus 3 log of 2, and that is the same as log of 40. And you can actually plug all this into your calculator because you have base 10 logs. So if you went log of base 5 plus 3 times log of base 2, you get about 1.6. And if you do log of 40, you get 1.6. So you can kind of double check your answer, but only if you have a base 10 log. So now here we have log of 125 over 4. So this is division. So remember that that means log of 125, and then I can say minus log of 4. And now the 125, well, that's 5 to the power of 3, and 4 is 2 to the power of 2. So I've gotten my object to the 5 and the 2 that I'm looking for. And now the exponents come down to the front. I use the power law. So I have 3 log 5 minus 2 log 2. And I'm all done. Now, one thing I want you to be really wary of, because this is a common error, if you have something like this, that can't be split up, right? A lot of people make that mistake. They see log of x minus 3 and they go, oh, well, that's just log of x minus log of 3. And oh, no, it is not, okay? Don't fall victim to that mess. You only subtract log when you are dividing in the original log. So be really careful that you're not abusing these rules and kind of doing them justifying them kind of half and like, oh yeah, I definitely saw that before. No, you didn't. Don't do it, okay? You can only subtract when you are dividing, and you can only multiply or add when you are multiplying factors. So be really careful that you do not do that. So let's look at a couple more. Find the exact value. Okay, well, here's that rule that comes into play. Well, first I'm going to go power rule, comes down. I get 4 log base 3 of 3, and then power rule comes down, minus 6 log 2 of 2, and then you go, oh, wait a minute, Herlar said something about, sorry, let me just fix the notation here, base 2 of 2. And yeah, rewind. Oh yeah, wait a minute. Hurdock says something about the log of the same base of the same object equals 1. So we just have 4 minus 6. And we get -2. So you can see that's why that is a super handy rule. Log to the same base as its object is just equal to 1. So essentially we cancel it out. And now let's look at log base 4 of 16. Well, if you can get the same object as you have base, then you can simplify this quite nicely. And 16 is 4 squared, so yes, please. And then we can bring the 2 down. We get 2 log 4, 4, and yep, cancel, cancel. We're just left with 2. So you can see that these rules all start sort of intertwining, and we start doing some pretty fantastic stuff with them. But I got quite a few more because there's quite a few examples, plenty more in your notes, but I just tried to cover a good sampling here. Now, in this case, we want to expand. And it's always important that when you're expanding or when you're simplifying, you know when to stop. You know when you can't go any further. Too often we kind of would expand all the way and then we kind of simplify back down or vice versa. It's like, no, you need to know when to stop. So let's see. So here I have an object in my log made up of 3 factors. So I can actually expand that out to log base 3 of 5 plus log base 3 of x cubed plus log base 3 of y to the 4. So I've split up those 3 factors. And now, can't really do anything here. I could calculate that number, but I'm not going to because it doesn't ask us to. So log base 3 of 5, because we could change of base that, right? And now here, this comes down to the front. And we get log base 3, 3, log base 3 of x. And then this comes down to the front, and we get 4 log base 3 of y. And if you look here now, there's no further we can do. There's nothing we can do. Even if you were like, well, what if you change of base? Well, okay, great. If you change of base, you get log base 5 over log 3. I'm just changing base to a base 10. Then you have 3 of log x over log 3. And then you have 4 times log y over log 3. Did we really simplify anything further? No. If we were solving for the log, then that might be helpful because now we have a common denominator, but we'll look at that in section 5.4, solving logarithms. So knowing when to stop, this is probably a good place to stop for this question. So now for the second one here, we're introduced to a concept that we haven't explicitly seen yet, but one that we should probably remember from earlier grades, and that's what is a root symbol with respect to an exponent. So first thing though is I'm going to notice division. So I'm going to break this into log root 7x minus 4 and then minus log 5. Now, what do we got here? I'm actually going to take this one maybe one step further than you might, just to show you what you can do. But now this is a root symbol, which remember the root means log all of that to the power of 1/2. And the reason I do that is because that exponent can now come down to the front. So now you get 1 over 2 log and then 7x minus 4 in brackets. You cannot break that up. You can't do anything more with that. You're stuck. Now I just want to show you a little bonus here. This is something that you will eventually do as almost a simplified tactic. If you have a base 10 log here, you'll notice you have a 5. Well, that's the same as log of 10 over 2, because 10 divided by 2 equals 5, which means you now have log, we'll do the division rule again, 10 minus log 2. And the reason I do that is because that's going to cancel. So all that does is that gives me 1/2 log 7x minus 4, but now minus 1 plus log 2. And sure, does that look any more simple? No, you could rearrange. That -1 goes to the back, but it's just a way of seeing how you can eliminate chunks of your log, because when we have to solve them, you're going to want to try to eliminate chunks. And this is a fancy little piece here that you'll notice in examples in further videos. So just to be aware of, but in reality, this, I'll just write it at the very top, this would have been enough. 1/2 log of 7x minus 4, and then minus log 5. Like that would be enough for here because we're not actually solving, but just know that this is a funky little additional piece. Okay, so a couple more. Now we're going to condense our log all the way down. So this time we are going to try and put it back together into one thing. And the most important aspect of that often is going to be put that and put that back as exponents. So this now becomes log base 2 of x plus 1 to the power of 4, and plus log base 2 of x to the power of 1/3. Because now you can start to condense your log back together. Now, before we condense fully, I'm going to rewrite x to the power of 3rd back as the cube root of x. And now you can see we're adding same log, same base, so we write it all as a product. So log base 2 of x plus 1 to the 4 times the cube root of x, and that all just gets condensed into one big log. Now, would we normally condense our log? Not usually. What we would usually do is we would be expanding our log, but I wanted to show you how to work both ways, from condensing to expanding and vice versa. So now let's do the one with the natural logarithms. Same process. Remember, we can treat a natural logarithm the same way we would treat a log base 10 log or a log base 2 log. And there's nothing we can do to this. But this 3 is the exponent of that, and this 4 is the exponent of that. So let's start there. So natural log 5 minus natural log x plus 1 to the power of 3 minus, I almost forgot to do it here, natural log x to the 4. Now, next place I want you to be real careful, double subtraction. Because doing quotient rule can get confusing. So if you have a subtraction and a subtraction, water bomb out the negative. So now you have negative this, and then this becomes a plus now of this. Because if you multiply that negative in, right, you're going to get a negative and you're going to get a negative. And it's just helpful to just make the division piece easier at the end. Because now inside the brackets, you do that product rule first. So now this becomes the natural log of x plus 1 cubed times x to the 4. And you do that because you're now adding in there, but then you're subtracting that whole thing. So now you get the natural log of 5 over x to the 4 times x plus 1 cubed. So it's kind of a common theme from grade 9 all the way through to probably calc at least. Always be careful with negatives. Negatives and brackets and water bombing and distributive method, same thing. I just say water bombing. And just get really, studious with what to do with negatives and when to do it, because that is where the majority of the mistakes happen. So particularly be careful when you have a double negative scenario, because this factoring out the negative just makes the condensing portion so much easier. And now we are going to do one that takes everything into account. So what's the goal here? Well, the goal is to fully simplify this thing, right? Now, you might look at this and say, I don't even know what to do. Well, let's just kind of take it one piece at a time. To start off, you'd think, well, this looks simplified. Sure, maybe. But let's start by seeing what happens if we condense these things together first. What can we? They have different log bases. So you know what we're going to do? We're going to start by doing the change of base law. And I'm going to make them all base 10 logs. Now the 18, I'm not going to put back into the exponent because I don't really want x to the power of 18. But I'm going to keep the 18 out front. So 18 times, and I'm going to change my base. So log x, so you take the log of that, and then the same log of that now. So log x over log 3. That's where I'm going to start with that one. Then we do the same thing, plus 12 times log of x over log of 9. And then minus 3 times log x over log 27. So that's step one. And the reason why I did that is because by looking at my bases here, and you'll get a lot better at identifying these things. I have a 3, a 9, and a 27, which are all powers of 3. So now you'll notice here's what's going to happen to my denominator. Now I have 18 log x over log 3 plus 12 log x over log 3 to the 2 minus 3 log x over log 3 to the 3. So what happens? Those exponents come down to the front. So now we have 18 log x over log 3 plus 12 log x over 2 log 3 minus 3 log x over 3 log 3. And yes, those 3's, 2's in front can cancel with the numerators just like we would cancel factor. So in our very back one here, the 3 cancels with the 3. And you'll also notice, and sorry, let me just, I wrote log x, that should be log 3, good. But the 3 cancels with the 3. Here, 12 divided by 6, or 2 gives me 6, and I can't do anything at the first one. So, but now that gives me a scenario where now I have 18 log x plus 6 log x minus log x, and now all over a common denominator, which is log 3. So now 18 plus 6 is 24, minus 1 is 23. So now I have 23 log x over log 3. I can't simplify this any further to cancel anything out. The only thing you could do is you could do the reverse change of base law, where this goes back to my object, and this goes back to my base, and the 23 stays. So I have 23 log base 3 of x. And I've simplified that whole statement down into one log statement. The reason why we would do this part is because if we were solving our log, which we'll do in section 5.4, we can then free up our x, because we only have one x left now, we can free up our x, we can then solve for what it is, figure that out. So tricks of the trade, we're going to put all these rules into play. There are a ton of practice questions for you in your workbooks and on my notes posted online. So please feel free to have a look. Remember, the goal isn't to do every single question. The goal is to do enough of the questions that you feel comfortable with any level of difficulty you see in there. All right, because there's a lot, and I don't want you to feel like you need to do this for hours on end. But thank you so much for this one. I really like logarithms because it's a puzzle, and it's what law do I use? How can I manipulate this? How does this thing fit here? How does that fit there? How can I simplify? How can I cancel? And the more you do it, the more fluid you become, and the easier you start to identify those patterns. So resilience is key here, and when in doubt, ask each other, ask me, watch this video, read your notes, okay, find the resources, but challenge yourself to try your best to connect as many of these rules as you can. Thanks so much, and I will see you next time.